If you have been watching the past couple videos, then you now know how to conduct inference for the parameters that we obtain from two groups. When we conduct this inference, there are several issues and cautions that we need to be aware of, and the purpose of this video is to bring these to your attention. We always talk about taking a random sample. A simple random sample is necessary for valid inference to population parameters. But oftentimes in a study, it is impossible to take a simple random sample. What then? In the absence of random sampling, you should still make an inference, but should clearly describe such inferences as approximations without the same level of confidence. Yes, I will still state that I have a 95% confidence interval, but I will also state that this interval is an approximation because we did not obtain a random sample. Correct probability statements are based on randomness. And so if we obtain a sample that is not taken at random, the probability statement is just an approximation. Why should we still make an inference? Inference calls attention to sampling variability and uncertainty. If you are to report the results of your study without making inferences, people who read your research results will make inferences in their own mind, and what they will infer is what happened in your sample. You don't want that to happen because you know that what you obtain in a sample varies from sample to sample. So by making an inference, you're bringing this to their attention. Inferences that are based on both random and non-random samples are inferences to a population that exhibits similar values on extraneous variables. What we would like to do is make inferences about the target population, but we almost never can randomly sample from the target population. Instead, we sample from an accessible population. Whether or not this sample is drawn at random, that sample is likely to have characteristics that are similar to those in the accessible population, including particular values of potential extraneous variables that may not be present or present in a different way in the target population. So we have to realize that inferences are really back to populations that look like the samples we obtain. They're not to a general population. I want to bring your attention to causal comparative research. Causal comparative research compares existing groups on variables of interest. That is, we're not conducting an experiment. There's no intervention. There's no randomization with causal comparative research. What we're doing is looking for potential causes rather than making a determination of cause and effect. The name here is a little bit misleading because only experiments lead to true cause and effect understanding. Causal comparative research is the comparison of groups to look for potential causes, but they cannot verify those causes. The methods of analysis that we use are the same as for experimental designs. That is, when we have two groups, it doesn't matter how you obtain those groups through sampling, and it doesn't matter whether or not you obtain those groups by randomizing to conditions. We use the same method of analysis. What's different are the conclusions. We're less uncertain about cause and effect when we did not randomize to conditions because of extraneous variables. So when we make inferences, we have to make it clear that the inferences that we're making are approximations, if there's no random sample, and are about differences in existing populations rather than due to a treatment, if in fact we're doing causal comparative research. The same conditions for inference and cautions apply to this research as to experimental research. What are the conditions that we need for valid inference? First, our two groups, or our experimental conditions, must be independent of one another. We cannot apply the treatment to one condition and then have the effects of the treatment trickle over into the other condition. This can happen if individuals in an experimental condition talk to individuals in the control condition, and the techniques that they are learning in the experiment they share with those in the control condition. This leads to contamination, and the conditions will not be independent of one another. Observations within conditions must be independent of one another. That is, we cannot measure individuals in pairs or in groups, but rather independently, and we cannot obtain individuals for our sample taking clusters, but rather we have to take individual by individual when we obtain our sample. The sampling distribution must be a normal distribution. You already know that all the parameters we've talked about, the mean, the proportion, the difference in means, and the difference in proportions, adhere to a normal distribution if we have a large enough sample size because of the central limit theorem. Well, what's large enough in a two-group study? For a quantitative response variable, the variable must be normally distributed, or the total sample size, that is both groups combined, should be at least 30. So that rule of 30 still works, and in fact, it works as a rule for the total sample, not for individual groups. For a categorical response variable, there should be at least 10 observations in each category for each group. So if we have two groups and we obtain data like yes and no from members of the groups, we have to have at least 10 yeses in the first group, 10 no's in the first group, 10 yeses in the second group, 10 no's in the second group. So you can see here we're going to need a minimum of 40 individuals in order for us to have a normal distribution of the difference in proportions. When does the central limit theorem work the best? That is, when is it most likely to give us very, very close to normal in our sampling distribution? Procedures are more robust. That means they work better for two-group studies when the sample sizes are nearly equal in both groups. The methods that you have learned about for analyzing two-group data are valid and they're powerful, but they're valid under a set of conditions, and these conditions are something that you should be keeping in mind and checking for anytime you do research in which you're going to have two groups and make inferences to population parameters.